Hello, and welcome to this course, Understanding AI and Intelligence Beyond the Usual Talk. I'm Zuhaib, and I'll be your instructor for this course. I have an experience in AI development, and together with my team, I deliver AI trainings. In this course, we are going to explore intelligence in a way you probably haven't heard before, not just as a technical idea, but as something which shows up in humans, other organisms, and even machines. By the end of this journey, you'll develop a thinking framework of intelligence, uncover how it exists beyond biological systems, how data powers it, and how all of it connects back to the world around us. This course is for anyone who is curious, whether you're a student wondering how AI actually works, or someone who keeps hearing AI buzzwords and wants real clarity. If you have ever asked, can machines really think? Then this course is for you. Hello, and welcome to the first session of the course. In this session, we are going to talk about a term we all hear very often, intelligence. We're going to dive into what intelligence is. We're going to demystify its structure and discuss about whether it's only limited to biological systems. So let's dive in. We begin our exploration by asking a fundamental question. What does intelligence mean to us? In today's world, we often associate intelligence with things like IQ. But is intelligence just about IQ scores? Or is it about life itself? Is intelligence something only living organisms possess? Now, to understand this better, let's look at a few simple examples. Imagine a soccer player preparing to score a goal. What's happening here is that the player is reading a lot of sensory data, is assessing the position of other players, the ball, and the goal post. So there's a significant computation involved, calculating the angle, the strength, and timing of the strike. Finally, there's a decision when to actually make the strike to score the goal. Now, this entire process reflects a structured flow of data collection and then computation and then a decision making. Let's turn to another example. We all heard about the story of the crow dropping pebbles into a jar, trace the water level. But now let's look at this example from the lens of intelligence. Now the crow assesses the water level, so there is an involvement of data collection through senses. Then there's a problem to solve. So when it's dropping the pebbles, it's again assessing the water level. Then finally, there's a decision about when to stop dropping those pebbles and start drinking the water. On to the next one. Let's turn to the example of self driving cars. So, what was once science fiction is now real. In self driving cars, they collect data from the environment using onboard sensors, cameras, GPS, and more. They compute, analyzing traffic signals, distances, and routes. Based on that, they make real time decisions when to slow down, when to make a stop, when to turn, or reach a destination. Despite being machines, they follow the same pattern of intelligence. So, whether it's a human being, a clever bird, or a high tech vehicle, intelligent systems aim to achieve specific goals. All of them, regardless of their form, operate through the same structured loop. This loop forms the core of intelligence. And the structure of intelligence is a three-part structure. The first one is data collection, which is about sensing and gathering data from the environment. The second one is computation, about processing and understanding the data. Finally, there's a decision making, taking action based on the insights. So, intelligence isn't about just IQ, it's about the ability to sense, process, and act. In simple words, it's the structured ability to turn information into purposeful action. Now, diving more into intelligence. So, when we think of intelligence, we often picture the human brain. But intelligence exists across a spectrum. From simple bacteria to humans, there's a gradation of intelligence. The bacteria have a simple form of intelligence, which is able to accomplish simple tasks, while on the other hand, humans have an evolved form of intelligence, which is able to accomplish diverse set of tasks. So, in the case of a bacterium, they are able to decide the direction of movement based on the sugar levels. So they sense the environment and they move in the direction of higher sugar levels. So we see that intelligence does not necessarily need a brain. And that's the basic form of intelligence, where you sense, then process, and then act. Now, based on this notion of the ability to accomplish diverse or versatile set of goals, we arrive at the definition of intelligence. So, as we saw, intelligence exists on different levels, and depending on how sophisticated the system is, we can say that it's the ability to accomplish complex goals. The more complex and diverse set of goals we are able to accomplish, the more intelligent we are. Let's take on this important question about whether intelligence exists beyond biological systems. Until now, we have seen intelligence in living systems, but it can definitely show even beyond biological systems in systems such as the mechanical ones. We see here the example of a rubber band, which resists when it's stretched and snaps back to its original position, although it's kind of responding to the external input and remembers its original position. In the second example, which is about the hysteresis curve of a material, we see that a material somehow remembers a magnetic field even after it's removed from there. Of course, there is no consciousness here, but they show mind-like properties. So this means that intelligence isn't limited to a brain or a biology system. It can exist in any system that processes information and then responds. So whether a brain, a rubber, or bacterium, intelligence is substrate independent. One powerful example of non-biological intelligence is artificial intelligence, which follow the same basic structure of intelligence like humans. So it takes in data, then it processes that data into information and turns it into an output, which can be a decision or a prediction. But unlike us, it's an intelligence which exists in a mechanical system. Unlike our brains, which are built on neurons, these systems run on silicon chips and circuits. We'll explore AI in detail in upcoming sessions. So in this session, we talked about intelligence and its basic structure, and we also learned how it exists beyond biological systems. Now that we have a deeper understanding of intelligence, it's time to go ahead.